Hello friends, welcome to my YouTube channel. I became engineer. My name is Pavis, and in the previous video we had to discuss operating characteristic of DC motor. Okay, so in this video we have to discuss operating operating characteristic of DC series motor. Okay, in this video we are discuss about this topic, operating characteristic of DC series motor. Okay, so in this DC series motor, there are three types: speed current characteristic, second characteristic is torque current characteristic, and third is speed torque characteristic. Okay, so first is speed current characteristic. Okay, and this is figure is this type. Okay, so the theory is uh, the mmf due to the exciting coils increase in the direct proportional to the line or armature current. So the value of flux varies with the load current according to the ordinary magnetization curve. Okay, owing to the armature reaction, the actual curve representing the useful flux falls below the open circuit magnetization curve, as shown in the figure. With the larger current, the magnetic circuit gets saturated and flux phi trend to the approach a constant value. Okay, so I'm write this: the mmf due to the exciting coils increases in direct proportional to the line or armature current. So the value of flux varies with the load current according to the ordinary magnetization curve. Owing to armature reaction, the actual curve representing the usual flux, the actual curve representing the useful flux falls below the open circuit magnetization curve. And curve as showing in figure with larger current the magnetic circuit gets saturated and flux saturated and flux tends to approach a constant value. Okay, so speed current characteristic: the mmf due to the exciting coils increase in the direct proportional to the line or armature current. So the value of the flux varies with the load current according to the ordinary magnetization curve owing to the armature reaction. The actual curve representing the useful flux falls below the open circuit magnetization curve as shown in the figure. With larger current, the magnetic circuit gets saturated and phi, actually flux I say to phi, okay, tends to the approach a constant value. Okay, so this is the figure of speed current characteristic. Okay, so the theory is from the speed equation it's obvious that speed is proportional to the back EMF. Okay, back EMF means EB, and I'm write this from the speed equation. It is obvious that speed proportional to back EMF EB, okay, and inversely proportional to flux per pole flux with the increase in armature current voltage drop in armature circuit and series field means equation is I RA plus RSE, okay, increase and therefore back EMF EB decreases as shown in the figure, okay, as shown in figure. However, under normal condition I RA plus RSE drop is quite small. Drop is quite small and maybe neglected. Okay, so from the speed equation, this is obvious that speed proportional to back EMF EB and inversely proportional to flux per pole. With the increase in the armature current, voltage drop in armature circuit and series field I in the bracket I our small bracket RA plus RAC complete bracket, okay, series field increase and therefore back EMF EB decreases, okay, as shown in the figure. However, the normal condition I in bracket RA plus RAC drop is quite small, okay, it's quite small and may be neglected, okay. Thus, if the applied voltage remains constant, thus if the applied voltage remains constant, speed n, okay, speed n is inversely proportional to flux if a curve is drawn between speed and input, okay, speed and input current I, it will be a rectangular hyperbola, a rectangular hyperbola before magnetic saturation up up to saturation point the magnetization curve is straight line. In this region, the speed decrease abruptly with the increase in input current. Okay, after magnetic saturation, after magnetic saturation, the flux tends tends to become constant and speed input current, sorry, constant and speed current, constant and speed current characteristic becomes a straight line and speed decreases slightly, speed decreases slightly due to voltage drop in armature and series field showing in figure. The speed become the speed becomes 0 when the input current is the normal short circuit current of the motor is that equal to applied voltage divided by motor resistance, divided by motor resistance. Okay, resistance means Ra plus Rse. Okay, normally this current is many times full load value, full load value. Okay, so I repeat this from the speed equation. Is the obvious that speed proportional to the back EMF EB and inversely proportional to the flux per pole with the increase in armature current voltage drop in armature circuit and series field. Okay, IRA plus RAC in the bracket increase the, therefore back EMF EB decreases as shown in the figure. However, under normal condition, I in bracket RA plus RAC in complete bracket drop is quite small, may be neglected. Okay, So thus if the applied voltage remains constant, speed n is inversely proportional to flux. If a curve is drawn between speed and input current I, it will be rectangular hyperbola before magnetic saturation, as up to saturation point the magnetization curve is straight line. Okay, in this region the speed decreases, okay, abruptly with the increase in input current. After magnetic saturation, the flux tends to become constant and speed current, okay, characteristic becomes a straight line, and speed decreases slightly due to voltage drop in armature and series field as shown in the figure. Okay, the speed becomes zero when the input current is the normal short circuit current of the motor, equal to applied voltage divided by the motor resistance Ra plus Rec. Normally this current is many times full load value. Okay, this current many times full load value. Okay, so from the speed current characteristic curve is it obvious that the series motor is variable speed motor. Okay, that is speed varies the variation in the line current with the decrease in the load. On a DC series motor, the speed increase and may become dangerously a high very light loads. Okay, I'm write this so you understand. From speed current characteristic curve, it is obvious that the series motor is variable speed motor, that is speed variables speed varies with the variation in line current. Okay, with the decrease in load on a DC series motor, the speed increases and may become dangerously high at very light loads. Okay, from the speed current characteristic the curve is obvious that the series motor is variable speed motor, that is speed varies with the variation in the line current with the decrease in the load on a DC series motor. The speed increase and may become dangerously high at lighter loads. So since on no load the speed is dangerously high, the machine may get damaged due to the heavy centrifugal force set up in the rotating parts. This is the reason that series motors are never started on no load, which is explained I'm below. Okay, I'm right is since on no load the speed is dangerously high, the machine may get damaged. The machine may get damaged due to heavy heavy centrifugal forces set up in the rotating parts. This is the reason that series motor are never started series motor are never started on no load. Okay, no load, which I explained below. So since on no load the speed is dangerously high, the machine may be get damaged due to the heavy centrifugal forces set up in the rotating parts. Okay, this is the reason that series motor are never started on no load. Okay, so I'm explain when the motor is connected across the supply mains without load, it draws a small current from supply mains flowing through the series field and armature. Okay, the speed tends to increase so that back EMF may approach the applied voltage in magnitude. Okay, the increase in back EMF weakens the armature current and hence the field current. This is cause again increase in speed. So back EMF, thus the field continues to weaken and speed continues to increase until armature gets damaged. Okay, I'm right this. When the motor is connected across the supply mains without load, it's drawn a small current from supply mains flowing through the series field and armature, the speed trends to increase so that back EMF may approach the applied voltage in magnitude. The increase in back EMF the increase in back EMF weakens the armature current, hence the field current, hence the field current. This causes again to increases until the armature. This cause again to increase in 1 second, increase in speed. So in back EMF, thus the field armature the field continues to weaken and speed continues to increase until the armature gets damaged. Okay, so when the motor is connected across the supply mains without load, it is drawn a small current from supply mains flowing through the series field and armature. The speed trends to the increase so that back EMF may approach the applied voltage in magnitude. The increase in back EMF weakens the armature current, hence the field current. This causes again to the increase in speed. So in back EMF, thus continuously to weaken to increase until the armature gets damaged. Okay. So to start a DC series motor, mechanical load is first put and then motor is started. I'm write this. To start a DC series motor, mechanical load is first put and then the motor is started. Since on no load, the series motor attains dangerously high speed, which cause heavy centrifugal force resulting in damage of machine. Series motors are not suitable for the service. I'm right this. Since on no load, the series motor mechanical load sorry series motor attains dangerously high speed, which cause causes heavy centrifugal force resulting in the damage of machine series motors are not suitable. Series motors are not suitable for the service. So first is where the load may be entirely removed, where the load may be entirely removed, and second is for driving by means of belt, driving by means of belt, because my shape to the belt would cause the motor run on no load. Okay, so since on no load, the series motor attains dangerously high, which cause heavy centrifugal force resulting in the damage of machine. Series motors are not suitable for this service, where the load may be entirely removed, and second is for the driving by means of belt, because my shape to the belt would cause the motor run on no load. Okay, the motor are suitable for the gear drive, because gears provide some load on account of the frictional resistance of the gear tipped in case of sudden release of load. I'm right is the motors are suitable for gear drive, because gear provide some load on account of the frictional resistance of the the gear teeth in case of sudden release the load. The load. Okay, so the motors are suitable for the gear drive because the gear drive provides some load on account of the frictional resistance of the gear teeth in case of sudden release the load. Okay, so however very small series motor may be used with belts, since in the case myself to the belts the comparatively large frictional resistance will represent an applicable load on it. Okay, I am right is however very small series motor may be used with belts, since in case of my shape to belt, the comparatively large comparatively large frictional resistance would represent would represent an applicable load on it. Okay, so the minimum load of DC series motor should be large enough to keep the speed of the motor within limits. In case the speed becomes dangerously high, the motor must be disconnected from the supply mains. Am I right? Is the minimum load on a DC series motor should be large enough to keep the speed of the motor within limits. In case the speed becomes dangerously high, the motor will be the motor must be must be dangerous then must be disconnected from the supply main. Okay, so however very small series motor may be used with the belt since in case of mishap to belt the comparatively large and frictional resistance will be represent an applicable load on it. Okay, the minimum load on a DC series motor should be large enough the speed of the motor within limits. Okay, in case the speed becomes dangerously high, the motor must be disconnected from the supply mains. Okay, so our the point E topic is operating characteristic of DC motor. The first point is completed, DC speed current characteristic. Okay, in second video we will discuss about torque current characteristic. Okay, and uh, also discuss about speed torque characteristic. Okay, so in this video we are discuss about the speed current characteristic. Okay, and main point is operating characteristic of DC series motor, and this is we are discuss about in this video speed current characteristic. Okay, so next video will be uh, in this add in the topic torque current characteristic and speed torque characteristic. Okay, so have a nice day, good day, and thank you very much. And if you like my video, so please like and subscribe my YouTube channel. Okay, so thank you very much.